What is a sub n if a sub 1 is 3? 99. What is d? 3, because you're adding 3 each time. Do we know what n is? No. Let's try and find n. If I wouldn't freeze this, there you go. Let's try and find n. So if I'm finding n, I'm going to use this formula and I'm going to substitute things, right? So my a sub n was 99. My a sub 1 was 3. I don't know what my n is, but I do know what my d is. So whenever we distribute these things out, we're going to have 99 is equal to 3 plus 3n minus 3. Make sure that you're always distributing out that 3 to both of those terms. So you guys can solve that for n. What is n? That's so funny. Like 90% of these people are in this class.
Well, I knew you didn't have 27 kids in here.
No. Yes, yes. He's fallen off the face of the planet. Has never turned in anything.
Just kids that are virtual.
Yeah.
And or who never show up.
Ah, well, it's fair. No, these are literally like,
Thank you very
you
much.
got it. All right, so we're going to simplify this. So we have 99 is equal to 3n since those 3's cancel out. So we're going to find that our n is equal to 33. So that is equal to 33. So if I'm looking at summation notation, I'm going to substitute all of my n's with that 33. Where I have 33 over 2 times 3 plus whatever my a sub n is, which is going to be 99. Simplify that further, we're going to have 33 over 2, or what, 17 point, not 17, 16.5 times 102. And so what do we get? I'm sorry, I can't hear you. 1,603. So 1603. 1603. Well, that's cool. What does that mean? I did a lot of work. Yeah, so the sum of all of those terms together, the sum of our series is 1603. Now, if we are going to write this in summation notation where we have our Riemann sum, we were to create this as a Riemann sum, I'm starting out at my first term. Yep. 83. Yeah, it is. Thank you. We're starting out on our first term, so n is equal to 1. Tomorrow we're going to be talking about whenever this one isn't equal to 1, okay, but we're just not even going to touch that today. So we're starting with n is equal to 1. Does anyone have any ideas for what I put up here? It's 33. So it's how many terms do we have total, right? What's going to be the last term that we're kind of counting in our series. And then over here, that's where we write our explicit formula. Well, on Friday, I walked through all the steps where I pulled back out this formula, this a sub n is equal to all of that nonsense, and walked you back through how to find the explicit formula. But as long as you simplify this right-hand side, whatever this right-hand side is simplified is going to be your explicit formula. So before you move anything to the left-hand side, because a sub n is still itself, even though we replaced it with 99, it's still just a sub n. Our explicit formula is just whatever we simplified this stuff to be. So the explicit formula for this one is going to be 3n. Sometimes you'll have, n with a coefficient and also a constant. So sometimes you'll have 3n plus 1 or something like that. It's not always going to cancel out where you have like positive 3 and a negative 3. So you just have 3n. It's going to be the whole thing, whatever that's simplified to. All right, cool. So let's do another guy. And let's do this. I want you guys to try, given that last example, what is the sum of the series? What is the sum of the series? And it is going to be -5 plus 2 plus 9 plus 16 plus blah, 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 plus 261 plus 268. You are going to need to find a sub 1. You are going to need to find a sub n. You're going to need to find d. What is d? Yeah, common difference. It's going to be your common difference. Then you're going to have n. If you can't find n, you're going to use your explicit formula to find n. Which is going to be a sub n is equal to a sub 1 plus n minus 1 times d. And once you have that, you are going to use your Riemann sum. I'm going to give you a little bit of time to do that on your own. So what is a sub 1? -5. What is a sub n?
268.
Very good, 268. What is d? It's 7 because you're adding 7 each time. What's my n? I don't really know that yet. I can learn. So let's go through and let's substitute things, right? So a sub n is 268 is equal to whatever my a sub 1 is. So that's going to be -5. I'm adding n minus 1 because I don't know what my n is yet. That's what I'm trying to find. And then I'm multiplying that by d, which is going to be 7. And Mason, since you missed, this might be ultra confusing, but just, you got it? Oh, well, never mind. Okay. As long as you understand formulas, it really shouldn't be that bad, but okay. So Mason, then why don't you help me out with this guy? I'm going to have 268 is equal to what? Okay, plus 7n minus 7. So I'm going to have 268 is equal to what?
7n minus 12.
Once you get to this point where you've simplified the right-hand side, go ahead and put this thing in a box. Okay, you haven't moved anything to the left-hand side. Everything stayed on the right-hand side. Go ahead and put that in a box so you know that that's going to be your explicit formula. If you need to put that back into a Riemann sum. So how do we solve this guy for n? Haley, help me finish this out.
I think I did something wrong.
Okay, that's okay. How do I, go ahead and help me solve this guy.
You add 12.
Yeah, add 12 to both sides. So I'm going to get, what, 280?
Yes, and then divide by
And
7.
yeah, can anyone do that in their head?
It'd be 40.
Yeah. 28 divided by 7 is 4. So 280 divided by 7 is going to be 40. Okay, so n is going to be 40. Now I'm going to substitute all of this stuff. I'm going to have S sub 40 is equal to 40 over 2 times a sub 1, which is going to be negative 5, plus a sub n, which is going to be 268. So I'm going to have 20 times 263. And what is that? 5,260. So 5260. What does that mean?
That's the sum of the series.
That's the sum of the series. Very good. If I were to write this in summation notation in a Riemann sum, what would I put down here? Yeah, n is equal to 1. What would I put up here, Emma? 40? And this is the tricky one. Can anyone tell me what I'm going to put here?
7 minus 12.
Yeah, 7 minus 12. Oh my gosh, I'm so proud of you. It's going to be 7n minus 12. So it's like a lot of steps just to get one thing, but it's really not so bad. Now, if you're just asked to create something, put it in summation notation, the only thing you have to do is this part. So let's do one more from 9.4, and then we are going to move on to 9.5. So you're going to have this, and it is going to say, what is the sum of the series? What is the sum of the series? But this time, you're going to be given the Riemann sum instead. So you're going to get n is equal to 1. You're going to have 70 up here, and you're going to have 5n plus 3. Can anyone tell me the sum of a finite arithmetic series, what that equation is, what that formula is? I'll go ahead and tell you it starts out with S sub n. It was on our quiz. Very good. A sub n. So it's going to be a sub 1 plus a sub n. Very good. So again, I'm going to need my a sub 1. I'm going to need to figure out what my a sub n is. I need to know what my n is. So let's think about something. A sub 1 I'm replacing my n with 1, right? So that's like saying 5 times 1 plus 3. All I'm doing is substituting. So a sub 1 is going to be 8. Now, if you'll remember, just like bear with me, if you'll remember, we've found a sub 1 whenever we've been given this, haven't we? When we've been given 5n plus 3 or some sort of explicit formula, we found a sub 1 before. We found a sub 7. We found like the first 5 terms in a sequence. Remember whenever we did those examples over and over again? We've literally done this before. It's just looking a little bit different. So a sub n in this case is it's actually telling us, can anyone tell me what my n is? 70. So this guy's actually telling me that I need to try and find a sub 70. Mhm.
70 instead of n.
Yep, so you're just going to put 70 instead of n. Off the top of your head, can anyone tell me what 5 times 70 is? 350. 7 times 5 is 35. So 5 times 70 is going to be 350. Then plus 3, 353. So a sub n is 353 and my n is 70. Well, now I just substitute. So I have s sub 70 is equal to 70 divided by 2 times a sub 1, which is going to be 8, plus 353. So I'm going to have 35 times 361. And what is that going to be? Anyone, once you have it? So 12, 635. And what does that mean? The sum of the series. It's the sum of the series. So you follow these guys. Let's go ahead and move towards 9.5. And I have made an executive decision that I've gotten a lot of questions about extra credit, right? So instead of assigning you homework tonight, I'm going to let everybody have the opportunity to do extra credit. So it's online. You have to put in the answers online. If you don't put in the answers exactly how my instructions say, if you put like random spaces and stuff in there or emojis like some people do, I'm not counting it right because I'm not going to grade 85, like a ton of extra credit. So if a bunch of people don't do the extra credit tonight, does that tell me that it's a waste of a homework day and that I should just assign homework instead? Yeah, kind of. So if you don't do it, I'm going to be like, oh, well, that was a waste of my time, so I should just assign homework. You know what the best extra credit is? Doing your stuff in the first place. Because the extra credit is a bunch of easy questions, but they count for literally half of your homework. So you have to do double the amount of work. So if you would have just done your homework, then you wouldn't have to do so much extra credit. All right, so let's do 9.5. So 9.5 is going to start out with a definition. And our definition is this. It is the sum of a finite geometric series. If our arithmetic series had a common difference of d, remind me what our geometric series has. R, it has a common ratio. So the sum of a finite geometric series is going to be S sub n. Oh my gosh. S sub n is equal to, you're going to have a sub 1 times 1 minus r, that's going to be raised to the n, all over 1 minus r. The things that you're going to need to find whenever you're using this is you're going to need to find a sub 1, a sub n, and R. So let's do an example. Our instructions say, what is the sum of the finite geometric series? And you are given 3 plus 6 plus 12 plus 24 plus a bunch of stuff plus 3072. On your own paper, I want you to try to find a sub 1, r, a sub n, whatever you think you can find. I'm going to speed this up. So what is a sub 1? 3. So that's my initial condition. What is a sub n? 3072. What is r, my common ratio? It'll be 2. If you remember, finding the common ratio is where you multiply everything by some r. So this guy is multiplying by 2 each time. So our common ratio is 2. So what's my n? Do I know what my n is? No. So I need to find it. If you remember, whenever we were finding the sum of a finite arithmetic series, we used the explicit formula for an arithmetic sequence. Well, now we're going to use the explicit formula for a geometric sequence. So let's do that. This is going to require a bit of review.
But could we just divide 3072 by 2 to get the answer?
No,
Okay.
but explaining why would be interesting. So this is also from the notes that we had. This is a times r squared, a times r cubed. So the increase is exponential. And that's why you wouldn't be able to just divide it by 2. So if you wanted to do some sort of shortcut like that, it would involve taking the square root of something instead of dividing by something. Okay. So we're going to use our explicit formula. Does anyone have the explicit formula for a geometric sequence? It would also be in your notes. You'll have a special place in my heart. Your notes have been awesome. Yeah. Our explicit formula starts out a sub n is equal to some stuff.
A sub n is equal to a sub 1 times r n minus 1.
A sub 1 times r raised to the n minus 1, raised to the n minus 1. So it's a sub n is equal to a sub 1 times r raised to the n minus 1. So let's see what things we've got. What is a sub n? 3072. What's a sub 1?
3,
What is my R?
2,
Now, do I know what my N is?
no,
I don't know what it is yet. So make sure that you write all the steps of this one down because it can be a little confusing. What I want you to do next is I want you to go ahead and get rid of that 3. So whatever you're being multiplied by in the front. Can anyone off the top of their head tell me what 3072 is divided by 3? What's 72 divided by 3?
we get 1,000 and
What's 72 divided by 3?
24.
24? Yeah?
Yeah.
And then what's 3,000 divided by 3?
So that's 240.
That's 24. Right? Well, no, you're right. Like you just take the individual components and put it together. So that's going to be equals 2 raised to the n minus 1. This is where it gets really fun. It gets tricky. You guys seen the TikToks where it's like, it's tricky, tricky, tricky. And then people like jump to the sides. Really bad. I am on TikTok literally all the time. It's terrible. Okay. So this thing, let's see. It's okay if you do not remember. We learned last semester, specifically chapter 7 at the very end of the year, how to solve for an exponent like this. Had a base of something.
Then you put square root something.
No, not quite.
No.
No square roots. Has a base b. We are going to visit our old friend logarithms. I'm going to put this guy up here. One of your extra credit things has to do with logarithms. So just giving you the heads up. So I want you to write somewhere like maybe at the top of your paper in really big writing. You're going to put log b of y is equal to x. Yeah. Then you have b raised to the x is equal to y. And if you had a little example of that, then let's say that we had 2 raised to something is equal to 32. Well, the logarithmic form of that is going to be log base 2 of 32 is equal to x. Yeah. So you need to write that really big somewhere because we're going to be using that a lot over the next couple days. So given that, if I'm going to put this into logarithmic form, I'm going to have log base what? What is
Log base 2.
log base 2? Very good. Of what?
1024.
1024, the thing that's on the other side of the equal sign, is equal to what?
No, n.
It's going to be all of this, whatever is your exponent. So it's going to be n minus 1. But no, that's great. So that is log base 2 of 1024 is equal to n minus 1.
So it would be 10.
So do we remember how to put this in the calculator?
It's second. Second log.
It is going to be,
Math.
it's going to be math. It's just you hit math. So if you want to write this on the side, you're going to hit math. You're going to scroll down until you get to log base, and then it'll let you fill it in. Do not just use the log button. Do not just use that guy. Do we remember why?
Because log is equal to log base 10.
Yeah, it has a base 10. Look at you. Oh my gosh, I'm surprised you remember that. Because if you just click the regular, like if you look at your calculator, it has a log button, but if you click this one, it'll be log base 10 because that's its standard form. So, okay, so we put that in the calculator and Josh told me what the answer was. So what is log base 2 of 1024? It's going to be 10. And we still have that n minus 1 on the other side. We can solve that. N is going to be equal to what? 11. Ta-da. Okay, so I did a lot of work. Not really sure to do after this. Well, we're using, do what?
Want me to go back to the timeline? Geometric.
Yes. We're going to go to the sum of a finite geometric series. So we're going to take this guy one more time. S sub n. We've got that a sub 1. So what did we say a sub 1 was? 3. We're multiplying that by 1 minus, what is my r? 2. What is my n?
11.
That is going to be the exponent to my 2. All over 1 minus, what is r?
2, so it'd be negative 1.
Yeah. And now this is just where you do a lot of the math. So what is 2 to the 11th power? Not quite. So it's going to be to the 11th power. So it's going to be 2 times itself 11 times. 2048. So you're going to have 1 minus 2048 all over negative 1. I'm going to scoot this stuff up. So it'll be 3 times what? Yeah, negative 2047. I'm like scooting this stuff kind of up here a little bit. Hope that's okay. Three times negative 2047 is what? My virtual guy got it. It's 3 times negative 2047.
Would be negative 6,141.
Yep, 6141 over negative 1. So it's 6141. What is that?
That is
The same.
the sum of the finite geometric series.
Yes, that's the sum. That's the sum of the finite geometric series. That is the answer. So let's try and do another one. Let's do this example where we have again, we're trying to find the sum of the series, but this time we have the example of 4 plus 12 plus 36 plus a bunch of stuff plus 972. On your own paper, I want you to try to find a sub 1, a sub n, r, and n. And I will go ahead and write the explicit formula up here to find n. So that's a sub n is equal to a sub 1 times r raised to the n minus 1. And then the sum of the series S sub n is equal to a sub 1 times 1 minus r raised to the n all over 1 minus r. So you guys can try and do that on your own. 4. What is a sub n?
972.
972. What is r?
3.
3. And we don't know what my n is. So I substitute these things. I have 972 is equal to 4 times 3 raised to the n minus 1.
It's person.
Do what?
Person.
Oh my God. Let me go home. So what do I need to do next, Emma? Yeah, I divide both sides by 4. So what do I get on this left-hand side here? Do what? 243. Is that what we got? Is equal to 3 raised to the n minus 1. What do I do now, Jesse?
Log base 3
Yeah, so you're going to have log base 3
of 243
of 243
is equal to a minus 1.
is equal to n minus 1. Very good. Very nice. So if you put log base 3 of 243 into the calculator, what is that? Is equal to n minus 1. So n is 6. I'll use that in the second part. So I'm trying to find S sub 6 is equal to 4.
This is
Mhm.
1 minus 3 to the 6th power
Very good. 1 minus 3 to the 6th power.
over 1 minus 3.
Very good. Over 1 minus 3. This is going to bother me. So I'm going to have 4 times, what is 3 to the 6th power?
It is 729.
729. All over -2.
Yeah.
So I'm going to have 4 times negative
728.
negative 728. Over -2.
Negative 2912.
Negative what? I'm sorry.
2912.
2912 over -2. So it's going to be
1456.
1456. What does that mean?
Something.
That's the sum of the series. That's the sum of the series.